Hi there, Dr. Maria Wheeler-Dubas here, Science Education Outreach Manager here at Phipps Conservatory. And I wanted to talk to you all today about something kind of fun. I wanted to talk about how things move. Are you ever just overwhelmed with how cool it is that nature has so many ways to incorporate movement into the lives of organisms? Some living things use 2 feet, some use hundreds of feet, some use no feet, and some use fake feet. Well, pseudopodia. We can't even remotely try to explore all of the different ways that animals and other wild things move today, but I wanted to at least explore the few of the strategies and trends that we see out in nature. Let's start with a party phrase for you all: visceral locomotory pistoning. Caterpillars use their gut to propel themselves forward in kind of a unique way. If that sounds wild, we need to remind ourselves of the tube that we all have that begins in our mouth, continues down to our stomachs, through our intestines, and then, out. Comprehensively, we call that whole tube the gut. Now, in us humans, with our upright bodies, the gut is a part of our torso, and then the rest of our length is in our legs. If you picture a caterpillar's body, though, that tube runs the length of their entire body. Now, what biomechanic researchers notice is in caterpillars is that as they move, the inner tube of that gut is propelled forward first, and the rest of their body is sort of catching up with it, so to speak. And here's the wild thing. Just because 2 different organisms look kind of similar, they could have wildly different movement strategies. Earthworms have both circular muscle groups and longitudinal groups of muscles in their long bodies, and they move by alternating contractions of these groups of muscles. This is called peristaltic locomotion.
Got it, Lakin and Natalie. Show us your best peristaltic locomotion? Okay.
All right, so Lakin's got the circular movement and Natalie has the longitudinal movement. On second thought, maybe earthworms do it best. And as if all of that wasn't already wild enough, though, with the emergence of vertebrates, nature produced some new options for movement. Lateral undulation. Ray-finned fishes, lobe-finned fishes, amphibians, and reptiles all move with their bodies arching from side to side. So if you've ever seen a fish or a shark swim, you might notice that its body moves side to side, just like a salamander or a snake when they're walking or crawling on the ground. And those animals who move with lateral undulation that have legs, they tend to have their legs splayed out to the side when they walk. So when they walk, they still have that side-to-side movement, and their legs are it's almost like they're push-up champions to be able to hold their arms out to the side like that, or at least it feels like they should be. Quadrupedalism. When something walks on 4 legs, we call that a quadruped. Quad referring to 4, and ped referring to feet. So within quadrupeds, we actually have a couple important different styles. So we mentioned lateral undulation, the idea of the body going side to side and the legs splayed out to the side as they're walking as they go along. But then we get mammals. So since mammals ultimately derived from an ancient line of reptiles, we've largely gotten away from lateral undulation. In fact, mammalian quadrupeds have their legs positioned directly underneath them, as opposed to out to the side, like most reptiles and amphibians. Then, within the mammalian quadruped world, there's a bunch of different styles of feet, and walking, and running, but they all seem to share that positioning of the legs being directly underneath them. Or they share a style of movement underwater that was ultimately generated from having your feet directly underneath you. So dorsoventral undulation. So while marine and aquatic mammals may live in the water, they don't swim with that side-to-side motion that we saw from the lateral undulation of fish and sharks. Instead, they move with something called dorsoventral undulation. And we had quadrupedalism, we also have bipedalism. So walking on 2 legs. Walking on 2 legs is how we humans walk around, and it's also how a lot of birds and other animals walk around. And sometimes plants are on the move too. When plants seem to move towards a main source of light, we call it phototropism. What's happening, though, actually comes down to hormones. In plant stems of the plants that seem like they're moving throughout the day, the plant hormone auxin will build up on the shaded side of the stem of the plant. This will actually stimulate the cells on that shaded side of the plant to elongate, making it seem like the plant is bending or growing towards the light. And actually, I'll add here that moving towards the light is called positive phototropism, but roots do the opposite thing and they go away from the sun. This is called negative phototropism. So let's see. visceral locomotory pistoning, peristaltic locomotion, lateral undulation, dorsoventral undulation, phototropism, all of this was just the tip of the iceberg. We all move in unique ways, whether we're plants, animals, or none of the above.
Until next time, thanks for joining and keep exploring the wild world around you.